Hello, everybody. Hello, everybody. Can you guys hear? I hope so. Hello, everybody. This is Daniel Suguwa, and now we are live for these launches. I'm not going to explain too much because uh, there's not many I can say here. So so we are going for the launch, okay? But before that, I think maybe uh, I can describe what happens in the nutshell. It's going to be short. No worries about this. Okay, so just give me some times. Okay. 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 So I think I can try show you guys here. Okay. So this is how it looks like. Around T minus 10 minutes, it has already gone into automatic launch sequence. Yeah, sorry for that. Automatic launch sequence for the launch itself. So uh, so most of the flight up until T minus 10 minutes, usually it will be under the mission control centers control. But right now, since they've already passed everything is go. So at T plus sorry, around T minus 10 minutes, they've already switched on all of the automatic computer on board inside the rocket itself. So it would check itself whether or not it's already live or whether it would check every components and also instrumentation inside. So that's pretty good so far. And for now, I'm not going to be very long here. It's something here. So we can discuss a little bit about the satellite today. The satellite that will be launched for today will be the Kinéis Kinéis. I don't know how to pronounce it properly, but hopefully this is okay. It's going to launch their on IoT satellite mission, which will be comprises of 5 satellites per mission. And now this is 5 hours 5 planned launch. So this will complete the entire constellation of it. And usually the purpose of this is mostly for Internet of Things. Basically, you can connect internets everywhere, just similar to how Starlink, OneWeb, and others right now in the market does. And it also can be used for, let's say, to identify the ship tracking using its own onboard AIS, which is automatic identification systems that will be able to track the ships and any maritime fleet in maritime fleet. Doesn't matter. It could be river. It could be around the sea. It will be able to track to. And also it's also can be used for similarly it also can be used for disaster recovery, maybe for props and what's on, because yeah, IoT. So what do you expect? Not much can we say here. Okay, and it's still good. So I'm going to discuss a little bit. For this rocket specifically, will be Rutherford 9 Rutherford rocket engines in for the first stage on, and also for the second stage will be only one Rutherford vacuum engine. So for this engine, it will operate on the electric pump cycle instead of gas generator cycle. Even because, as you know, gas generator cycles, in order to move all of the propellant, basically the oxidizer and fuel, it will use the turbine, right? And to move the turbine, usually what they will do is they will pre-burn it first inside the gas generator here, and then it will move the turbine. Only then it will ignite here. It will just mix together here and ignite. But for the electric pump, the difference is that there is no gas generator involved here. Instead, the battery will move the motor, or basically just a replacement of the turbine here. It will move the turbine, move all of that propellants, go downward into the combustion chamber, and ignite it here, and that's how the operation in the nutshell. And looks like we are still good around T-4 minutes. Okay, this is how it does it operate. Okay, as you can see, this is how. Credit to everyday astronaut. Okay. Oh, okay. This one is higher resolution. I should delete that lower. Okay, but as you can see, this is how it works in the nutshell. And also for this mission, how it also going to looks like. Okay, this is pretty good. So let's go with here. I think rather than, okay, I'll let the music company. Okay, this is how it looks like. And before that, if I remember, around T minus how something, you can see this is how the satellite looks like.
What they looked like.
How it actually looks like inside the inside the payload assembly. As you can see, this is how it looks like on the payload shot. At the payload shot, this is here. 5 of it. It's actually organized in this way.
Absolutely. And how cool is it that?
So, okay.
Go for auto sequence start T minus 2 minutes. LDs go for launch.
Okay, for auto sequence start, it would be around T minus 2 minutes and counting. So, and also I can give a little bit description for this Kinéis. This is not like fully private. This is more like a public private mission here, because this company also currently operates the Argo system. That's basically says an international scientific collaboration between TNES, basically a French-based agency, the National Ocean and Atmospheric Administration (NOAA) from the US, the European Organization for the Exploitation of Meteorological Satellite, which is EUMETSAT, and the Indian Space Research Organization, ISRO, or ISRO, if you guys like. So, and this is basically a 30 kilograms class nanosatellites here. Like it says here, it integrates IoT technology and also ship tracking automatic identification system. So this is how it looks like, and it has a lifetime of 8 years. So basically, from the launch time, it will be up until it can be used up until 2032, and max will be around 2033. So yeah, and also it will be deployed around 650 kilometers above the Earth, of the inclination of 97 degrees, which will be around the polar orbit launches. I mean, as you guys know, if you guys know your geography,
Stage 1 and 2 tanks are pressed.
New Zealand is basically located in the southern hemisphere of the Earth, so it's pretty logical why they will launch on 97 degrees of course. And the launch itself, while this is not an SSO launch, it's on synchronous orbit launches. This one still needs to be very accurate. Because why? Because if it's not accurate enough, the even just slight deviation of the satellite will cause us, let's say, for example, a little bit synchronization off of the satellite, or maybe, let's say, for example, maybe could cause us something else. So I would just close the music. So let's go for the launches.
5, 4,
3, 2. Okay, 9 Rutherford engines in ignition, and lift off from the launch pad of the from the Mahia Peninsula, New Zealand, and lift off from the LC Launch Complex 1A. And now should be around T plus 10 minutes and counting. And forgot to mention that this rocket is powered mostly by Paralox or kerosene. Basically, mostly like a top chill.
Stage 1 propulsion nominal.
Okay, stage 1 propulsion is nominal, and speed velocity is around almost 700 kilometers per hour, and altitude is 3.5 kilometers.
At launch conference 1. Keep an eye out on those dials at the top of your screen there to see electrons.
Yeah, it's mostly powered by Kerolox, which, if I remember, to be around top chill kerosene for maximum, for slightly maximum density. Okay, should be already max Q. Okay, should be already max Q and already supersonic. And yeah, it's already supersonic even before the. Yeah, okay, max Q already hit, but already. But it's already reached
just over 17 kilometers in altitude.
Supersonic even before the airplane altitude. I mean the typical commercial airplane altitude, which should be around 35,000 feet or around 10 kilometers something like that.
Of Electron made from
So
carbon composite
good. Okay.
split into 2 parts.
And this is the rocket cam. It looks pretty nice here. Even though right now we are looking at lots of cloud coverage, but it's pretty typical. My places has a lot of cloud right now. So
Stand by for Miko in roughly 30 seconds.
okay, stand by for the Miko. Let's see. And also, I'm not going to stream too long because I do need to chase the boss, of course. So yeah.
15 seconds to staging.
Okay, 15 seconds before staging. So it should be around T plus 2 minutes and 30 seconds, and should be cool. Okay, let's watch. It's most
Miko confirmed.
okay. Miko has already confirmed, and interstage confirmed here. And also, it's going to be Rutherford. Okay, Rutherford vacuum engine has already ignited. And also, I need to also mention in this mission, because they use electric pump. Because this rocket engine is essentially an electric pump-fed engine. Of course, it's going to use the batteries, and because batteries density is not as good as, let's just say, even a comparable gas generator rocket. So of course they have to ditch the second battery here. That's one thing for sure. And here's the very short separation here.
It's good
okay, and looks good.
For the final
and you can see it's looking very nice there.
We are now
Yes.
just over 3 minutes into flight, with
Okay.
less than 6 minutes remaining in the second stage burn.
Yeah, and also forgot to mention that maybe they have, yeah, they also have Curie, Curie Curie upper stage there. Mostly, if I remember, technology is actually derived from their VLM, viscous liquid monopropellant research, actually back around 2013 2014, if I remember, and they already patented it. So yeah, and if I remember, it's composed of something related to aluminium, aluminium whatever propellant is inside of it. That can be restart for how many multiple times there.
got the fuel and ox
But for
levels
the
are displayed,
hyper-QE
and with the
upper
kerosene at
stage,
about
which is
73%
not used in this
and liquid oxygen
mission,
about 73% as well
it's
remaining, it is a
the
great
ingredient is
sign
not
that
exactly
everything is
known,
functioning smoothly so
so
far. Let's keep an
we
eye on
don't
those
have
numbers
any
as
idea
we
for
get
the
closer to
hyper-QE, but
staging.
for QE upper stage, which is this mission, we already have the idea. One thing's for sure. Okay, so for now, I need to re-mention again that this rocket is mostly powered by kerolox or kerosene, mostly a subchill around negative 60 plus degree
Stage
something
2 now traveling at over
Celsius
11,000 kilometers an hour,
for
with that nozzle
slight
glowing bright over
how do I say, for
179
slight
kilometers above Earth. A beautiful
specific
view from our
impulse
onboard
and
cameras
also
here.
density
How cool is
advantage
space, right?
Oh, absolutely.
with
That
the
is
liquid
always a treat.
oxygen
Now, when we first
as
launched
the
Electron, it
oxidizer.
took with it a few world firsts,
So that's how
including the unveiling of our
mostly
3D
operates.
printed Rutherford engines.
For
Instead of
QE and
using a
hyper
traditional
QE,
gas
just like
turbine, the fuel
for
pumps inside Rutherford are
QE and
powered by
hyper QE,
electric
it's
motors.
just like as
Those
we've already
motors are
mentioned
powered by
before.
batteries.
Yeah, it's
During flight, we use
it's
up all
whatever
the power
it
in
really
one
wants
set
to.
of batteries
So,
before switching to a fresh set. But rather than carry the dead weight of those spent batteries all the way to orbit, we jettison them to give us more available mass for customer spacecraft.
yeah, so that's the
nifty
reason
little
why they have
maneuver
to
is
ditch
called
those
battery hot
batteries.
swap, and it's coming up next.
Okay, so coming up next for the battery hot swap, which will remove one batteries that basically depleted, and another batteries there will be will be used to keep pushing forward for this mission.
Holding nominal, approaching hot swap in roughly 30 seconds.
Okay, approaching for the hot swap. Let's see. The battery should be ditched out. Okay, altitude right now is almost 202 kilometers.
Throttling down.
Okay, velocity or speed is now has already reached around 15,000 kilometers per hour. So let's see and witness the battery hot swap here as we
Jettison confirmed.
okay, so you can see the battery jettison has already confirmed.
You
So
caught it
the
on your screen there. Battery hot swap has been successful.
yeah,
The next major milestone
and
will be
it will
Suguwa,
re-enter
or
back
second engine
to the
cutoff,
Earth,
coming up in
and
about
I
3 minutes.
expect that
At
the
that point, the Rutherford engine will
environmental
throttle down
consequences
before
will
shutting off
be
completely in
mostly
preparation
minimal
for
here, so
K-stage separation.
mostly no worry.
After that, it's all up to the K-stage
And
after a close period to deploy the payloads.
the rocket cam telemetry color looks looks funky and looks funny there, you know. I mean, I've as far as I know, I've not yet seen this before, so yeah, a bit surprised for me. And I've already have something for my breakfast. It's hot chocolate here, and I need to go to the class after this. Okay. Yeah, in case you see my avatar just move there, I just drink it, and speed or velocity is almost
Now's as
20,000
good a time
kilometers
as
per
any
hour.
to remind you that there's
Altitude is
more than just
206
rockets in this lab. And if you want to have
Okay,
views like this
it's
be a part of
slightly
your
descending,
everyday,
but you
there's a
don't have
place
to
in
worry.
space
This
for
is
you.
mostly for
Right now, we have roles in our
gravitational
machine shop
advantage
teams,
push,
so if you have
push, or
experience
basically
with
if we
5-axis CNC
if we
machines,
use a little bit of
editing and
light
programming,
energy
or
there,
experience
we
in
just
Siemens or
slightly
NX,
lower the
then we
altitude.
want to
We
hear from
can
you.
at least
Visit
aim for a bit higher altitude there.
rocketlabyusa.com/careers and get in touch
So
with
a
our
little bit
talent
higher
acquisition
altitude
team
around
as
the
soon as
apogee
we
there.
can.
They will ignite should be igniting the QE upper stage there to finally circularize the IoT satellite itself by the Kinéis, of course. So let's see. We shall see soon. We are going to witness the second stage, second stage.
Burn out tech mode.
Okay, cut off. So let's
Not
watch
long
there.
now until that second stage engine throttles down and shuts off ahead of kick stage separation. The stage operator in mission control will call it out
Funny.
across the nets, so
Funny
keep
look
an
by
eye on
my
the nozzle
avatar.
on your screen as it cools down.
Because of why? Because the space itself doesn't have much of the atmospheric in there, so of course it can radiate itself way faster than if it's on Earth. Okay,
Confirmed.
and looks like Seco confirmed.
Stage
Okay.
separation confirmed.
Okay,
There you
stage
have it.
separation
Electron's
confirmed.
second
Now
Rutherford
the
engine
upper
has shut
stage
down. The
Curie
kick stage
has already
has separated for the coast phase as planned.
take
For the
over
next
the
45
task.
minutes,
Okay,
the kick stage
so
will
I
pass
think
around Earth
that's all.
until
I'm
it
not
reaches a
going to
precise
stream
point
too long.
where the tiny 3D printed Curie engine will ignite to raise the orbit ahead of payload deployment.
This phase is an important period where the spacecraft is essentially coasting through space,
Okay,
following
I've already
its
finished my
calculated trajectory without the need
So
for
this is
engine
guys.
turns. During this time, our team will be closely monitoring all systems to ensure everything is functioning smoothly and according to plan.
Yeah, so as you could hear. So this is a ballistic coast phase flight. So engine will not ignite and will wait until the highest apogee, or basically highest altitude there to finally circularize the orbit. So that's one thing for sure. Okay, so I think that's all. I'm not going to stream too long. I need to ride for the bus. So yeah, ride the bus for the class, of course. So thank you so much for watching. Take care, everybody. This is Daniel Suguwa signing out.